Good morning to all. Myself, Dr. Arun Nehemiah from Aerospace Engineering Department. Today, I am going to take one topic from third year Aerospace Engineering subject. So, in that subject name is EFT for Aerospace Applications. So, in that unit name is Finite Element Techniques. So, in that finite element techniques, so what is meant by finite element? So, it is a techniques. It can be used for the all the structural and non-structural problems. So, it is a numerical techniques used to approximate solution to differential and integral equation. So, in the differential and integral equations, it will be utilized for complex problems domain into smaller, simpler elements, solving equations for each elements and combinations of structural and non-structural problems. These are all the things it will be utilized for this one. So in that the main concept of the FEM, it can be utilized for the many things. So in that FEM problems, it will be complicated to geometrics, loadings, material properties. So in that the geometrics either a structural or non-structural, and loadings means a loading, it can be classified into three types. First one is a point load, next one is a uniformly distributed load, and the third one is the uniformly varying load. So in that point load, it will be lies on the this is a beam. So in that things, the point load, it will be lies on either the point of the beam, and in that uniformly distributed load, it will be like that in that manner. Next one is a uniformly varying load. So here if the load applied on this area, in that load impact, it will be vary. For example, for in this region, the load impact is higher. So for in this region, the load impact is lower. So these are all the things it will be for that types of loadings. Next one is the material properties. So in that material properties, so which materials is suitable for the design? For example, if we take a one chair design, so in that chair design, we are using the many type of materials like plastic chairs, PVC chairs, and steel chairs, composite chairs. These are all the chairs it will be utilized for these selections. Next one is that how does finite element analysis work? So in that things, in that finite element analysis, they are making the grid generation. So like a survey method. So in that survey method, so we are not able to find out the unstructural elements. For example, this is a one space of geometry. So in that geometry, we are not able to miss that properly. So here we have cut the each section. So in that each section we have cut it like that manner. And the next we have taken the structural meshes. So in that meshes, it will be the each nodes. It will be created on the each element. So by using these cases, so we can create the mesh. So in that mesh, it can be classified into many types: structural mesh, unstructured mesh, tetrahedral mesh, triangle mesh, and many case of mesh it will be utilized for this survey. So here the in that mesh it will be depend on the material selections. So in that material it will be selected based on the density, temperature, thermal conductivity, and melting point of the material. These are all things we can choose on for before the finite element analysis. Next one is C for regional survey. So in that case, the large size of materials can be taken for this survey. So in that things we need to check the which point we are going to apply the load. So if you apply the load, what will happen during the loading conditions. These are all things we are taken for this survey. And the next one is the node selection. So in that node selection, it will be selection based on the material. So in that, for example, the lighter materials, we can fix the load in far away. For heavy stronger material, we will fix the nodes in very short range. So thank you. We will catch you on next sessions and next video.